have to say I feel like a little bit of a rabbit in a headlight here. I don't often do public speaking. And so just to try to put it into terms I think hopefully we can all relate to. Standing here right now, I feel like a single data point that is navigating its way very, very nervously across a large and impressive data set. And I can already sense the spatial part of my brain has performed a nearest neighbor analysis and has already found the exit to the door. But having said that, I'm a passionate geographer, and so it's a real honor and a privilege to be representing AWS at this conference. And I want to thank Helen, Josh, and Javier and the rest of the Kato team for inviting myself and AWS to be an active contributor to this conference. So yes, my name is Dean McCormick. I'm an account manager with the Aerospace and Satellite business unit at Amazon Web Services. And what I'm going to be talking about today is essentially how we can use some core services from AWS Cloud to support spatial data on its journey along the data lifecycle continuum. So from ingesting to storing to processing to running analytics and essentially getting intelligence, actionable intelligence into the hands of the consumer as quickly as possible. And at the end of the presentation, I'll also talk about an innovative use case whereby we're linking AI to location. So maybe just a couple of quick words in terms of who we are and what we do within Aerospace and Satellite. We're fairly nascent as far as the wider AWS organization is concerned. We were established around 5 years ago. And we were established by bringing together space and cloud expertise in order to be laser focused on our space customers and to support them on their missions, missions that address all aspects of what we call the space value chain, so both the upstream and the downstream. And our mission as a business unit is really to help our customers design, to launch, to operate and maintain space systems, and then to draw insights rapidly and efficiently from space data. All, of course, by leveraging AWS Cloud to take care of what we call the undifferentiated heavy lifting so that our customers and our partners are able to be freed up to go out and innovate. And so as an account manager, I feel honored and privileged actually and very excited to work with many customers and partners in the downstream part. Is that my phone? I think it is. I can find it. I've lost it. Anyway, hopefully that goes away. So as I was saying, I get to work with a number of very innovative partners and customers who are doing some fantastic work and making a meaningful impact on society. So I primarily work on the downstream parts. You can see many of the references here. I don't personally work with Kato. I have another team that does. But we work with customers and partners that cover a range of different industries to provide insights into those industries, from maritime domain awareness to agri-tech to geospatial intelligence or defense and intelligence rather, as well as within infrastructure monitoring. Sorry, let me just go back to that slide. And working with many of these customers and partners, particularly in the downstream part, we often find that there is a challenge that's universal that they are faced with, and that is often the need to shorten the life cycle from sensing something from space, an activity, an event, or change, to taking action very quickly, because ultimately, the quicker we can get those insights, it can be critical to saving lives, protecting people's property, and critical infrastructure. But I think it's also fair to say that the space industry for some time now has probably been over-indexing to some extent on providing the clearest, the sharpest, the highest resolution imagery. And we're starting to see a paradigm shift, especially with digital transformation, whereby it's not how small of an object you can see from space, That's really critical. It's how quickly you can deliver those insights into the hands of a decision maker. And so we would argue that latency now has become the new resolution. So from an AWS standpoint, what is the starting point? And I'm going to sort of talk about satellite data here. First of all, we've got to get it into the cloud. And how can we do that very quickly? And so at AWS, we operate a fully managed service called Ground Station. It allows a satellite operator to connect to, task the satellite, and then eventually downlink data to one of 12 antenna locations, which are distributed around the globe, all without having to manage, or at least build and manage that physical infrastructure. And once that data is received, then we can use AWS's dedicated high-speed network to land that data into currently one of 34 AWS regions around the globe. And we're announcing the launch of another 4, including the European Sovereign Cloud later this year. And of course, once we land that data into AWS Cloud, customers and partners can start to work with the data. We have a range of 200 plus fully featured services, from enhanced compute, storage, networking, analytics, IoT, AI, ML, generative AI, and I'll be talking about some of those. So where does the data typically end up? S3, simple storage service, which is an object-based storage solution, which is for many of our customers an authoritative data store for geospatial data. It's highly scalable, it's highly secure, it's highly durable, and it's highly resilient. From a scalability standpoint, this time last year, my colleague Phil Cooper stood on the stage and stated that at that time, I think it was at the end of 2023, there were 270 trillion objects being managed globally by S3 as a service. Fast forward another 12 months, there are now 400 trillion objects being stored in S3 around the globe. So it sort of gives you a sense of how scalable this is as a storage solution. From a durability standpoint, we often talk about 9/11s of durability, but what does that actually mean? It means if you had 10 million objects stored in an S3 bucket, the probability of you losing one of those objects would be 1 in every 10,000 years. Or perhaps put slightly differently, if you had 100 terabytes of data and you were immortal, you'd probably see multiple ice age events or major tectonic plate movement before you would conceivably lose one of those objects. And then finally, just in terms of security, we often talk about the shared responsibility model at AWS, where we are responsible for the physical security of the infrastructure, whereas customers and partners who own data are responsible for what you put inside the cloud, and we provide all the access control and security measures so you can decide where the S3 bucket resides, in which region, and who can access it, etc. At AWS and Amazon per se, we have a very peculiar business culture. You'll often hear Amazonians, as we called, talk about leadership principles. And there are 16 of them, and please don't ask me to list them all, because I'll probably forget one and I probably won't have a job after this. But I want to call out 2, and that's customer obsession and bias for action. So from a customer obsession point of view, 90% of all the services that we've released into the market in the history of AWS have really been down to what our customers have asked us to deliver, not what we think that they need. The other 10% is really down to bias for action and what we call strategic innovation. And there's no better example of this than a service called Amazon Aurora. If you haven't heard of it, it's one of 8 relational databases that we've released into the market. It is cloud native, it is cloud optimized, it is both Postgres and MySQL compatible. It costs 1/10 of that of an enterprise-grade relational database and is 5 times more performant than MySQL and 3 times more performant than Postgres. So these factors have made it the fastest growing service in the history of AWS and is used by thousands of customers around the globe. So if you were let's say you were a retailer, a modern retailer, and you had a fleet of delivery vehicles, and those delivery vehicles were traversing the countryside, delivering your products, you could leverage Amazon Aurora to store, process, and maintain large volumes of operational data, as well as your real-time location data. And then with the Postgres extension, we can obviously manage complex spatial relationships and do things like coordinate transformations to deliver additional insights, geographic insights. But what happens if you wanted to augment your existing data and provide additional geographic context? We have Amazon Location Services. And with Amazon Location Services, you can use the geocoding service to accurately do addressing. We can identify nearby points of interest. We can use the routing service to identify the quickest and the shortest routes for your delivery vehicles. We can track them using the mapping service and then use geofencing to be able to identify as and when those vehicles might enter or exit their delivery zones. And as that organization starts to scale, of course, you're going to start to accumulate a lot of historical data. And so with that in mind, we released Amazon Redshift. Amazon Redshift is our data warehouse that can scale to petabytes of data. And because it supports columnar-based data storage models, it's a perfect solution for online analytical processing. It comes with 118 spatial functions, including support for H3. And because it's native to AWS, it integrates very tightly with Aurora. So on the one hand, Aurora you could use to manage and process your daily operational data, and then your historical data could be handled by Redshift. We've also started to leverage AI, and in particular the Amazon Q service. So if you're doing or performing complex analytical tasks, then we can leverage natural language interactions so that we can quickly generate queries so that we can deliver insights from essentially exabytes of data. And then, as I said, we have a very tight relationship with Kato, and so Amazon Redshift integrates tightly with Kato as a platform, so we can take complex geospatial data, we can transform that into nice interactive maps, and so business leaders can make effective decisions around their business needs in whatever operations that they are performing. We are, I would say, over the last decade and a half, we've sort of entered this so-called new space economy. And depending on what analyst reports you believe in, over I think it was since the end of 2023, it was said that the new space economy was worth around $570 billion US. Fast forward to 2035, and it's expected to exceed $1.8 trillion US. And so what is fueling that? It's lower launch costs, it's smaller, cheaper satellites. And of course, the end result of that is that we have this growing constellation of satellites that are capturing and recording and sensing the Earth like never before. And of course, we now have this sort of data tsunami effect, which is overwhelming the image analyst community to the extent that the National Geospatial Intelligence Agency, or NGA in the United States, has openly stated that just to keep up, they would need 6 million analysts. But of course, in a very short space of time, we've seen rapid development within AI, machine learning, and generative AI. And at AWS, we've been at the forefront of developing purpose-built AI, ML, and generative AI capability. And so starting at the infrastructure level, we develop our own chips which are purpose-built for training and inferencing. They're called Trainium and Inferentia. And at the end of last year, we announced the second generation of those chips, which are delivering between 30 and 50% better price performance than traditional GPU-based solutions. And so our customers and our partners are getting tremendous economic benefits out of using these chips in order to reduce the time to train models. And talking about training, we have Amazon SageMaker, which allows the data science community to collaboratively design, build, and deploy models that can extract features from satellite imagery and street-level imagery as well. And then we're also bringing generative AI closer to geospatial applications with products like Amazon Bedrock. Amazon Bedrock is a serverless solution that enables, via a single API, access to foundation models from leading AI companies. So Anthropic, AI21 Labs, Cohere, Mistral, Meta, Stability AI, and earlier this year we announced Amazon Nova. So we are giving you choice so that you can have a foundation model that best suits the application that you're trying to develop. Then, of course, for the developer community, we have Amazon Q Developer to boost productivity. And so we can use these tools to support things like optimization of some of the, sorry, now I've lost my train of thought, so I'll skip that bit, and I'm running out of time. So. But I think you get the idea about Amazon Q Developer in terms of a tool to help our developer community build applications. What I wanted to say was, and sort of trying to end off on my presentation, is that with all the talk of AI, ML, etc., I think there's one glaring sort of limitation as far as AI is concerned when it comes to geospatial, and that it does not understand location. It does not understand the real world that we live in. And so we are looking at ways in which we can bridge that gap. And so through a initiative that we ran at the end of last year, it was a collaboration between AWS and the Taylor Gordon Institute. We announced a generative AI for geospatial challenge to really try to push the boundaries as far as new generation geospatial applications was concerned. And so just imagine, if you will, if you were standing outside this building as a tourist and looking back at the entrance to this building, and you had an AI system that you could ask to help you understand exactly where you are located, and then you could ask questions of that AI, and it could respond to those questions based on what was in your field of view. And so one of the outcomes of that initiative was an application that was developed by a company called, well, it's currently under development by a company called Zephyr in the United States. And this is sort of the early sort of experiments around that application. It's leveraging AWS and the back end, so some of the services that I've mentioned, S3, in terms of the relational database, it's using a graph database called Neptune, as well as Bedrock in terms of gaining access to, in this case, Llama as a foundation model. The front end we're using, they're leveraging rather tools that we all use and know in our daily lives. So using smartphones and smart glass technology with embedded GPS and IMU. And it's by leveraging GPS and IMU and motion sensors that we're able to create a geopose. So geopose really tells the system exactly where you are and what you're looking at. And then we can connect to the large language model to essentially get access to mass amounts of information about that particular location in real time. And the beauty of this capability is that it doesn't require expensive and complex vision mapping solutions, and therefore provides a location-enabled AI solution that is both scalable and accessible. And so you can imagine the types of use cases for this type of technology in areas such as retail, in military applications, etc. So to end off my presentation, I wanted to summarize the following. As a data science community, as a geospatial community, we are at the intersection of technologies: cloud computing, AI, geospatial technologies, and these are helping us sort of fundamentally transform the way in which we understand and view our world. And so this presentation has really been about a journey of spatial data from remote sensing to insights, leveraging technologies that are making things a lot more efficient, but also technologies and a journey that is actually becoming quite crucial. But it's not just about the technologies, it's also about democratizing access to spatial data, to Earth observation data, in a way that more people and consumers can get access to it. But it's also not just about building applications. It's about how do we democratize the access for consumers to be able to get actionable access and intelligence from geospatial intelligence very quickly and very rapidly. And our customers and our community, rather, really need to be focused on not just being observers of this transformation. It's about how we can all be active participants and architects of the next generation of geospatial technologies. And with that, I'd like to thank you for your attention and available for any questions. Thank you.